Alright, in this video we're going to go ahead and look at solving systems of two equations and two unknowns by what's called the elimination method. Um, this is probably my favorite method, along with the substitution method as ways of solving systems of linear equations. So the goal is to eliminate either the x or the y. It doesn't matter which one we eliminate, we just want to go for the path of least resistance. Sometimes it's called the elimination addition method because we're adding the two equations straight down. So for instance, in this particular system of equations, you see you have a negative 3y in the first equation and a positive 3y in the second equation. So that's ready to go. If I add negative 3 and 3, those are going to cancel each other out. So that's exactly what I'm going to do. I don't have to do anything else with that. So I just label them equation 1 and 2, and I add straight down. So 3 plus 9 is 12, and those are the x terms. The negative 3y and the 3y are going to cancel out. When I add them, it's 0, so I don't even write that down. And then on the right hand side, 12 and 24 makes 36. Okay, and then to get rid of the multiplication by 12, we'll divide both sides by 12, and we will get x is equal to 3. Now that I have one of my solutions, it does not matter which equation I plug it into. I can plug it into 1 or 2 to find the y value. So I'm going to go ahead and plug it into the first equation because it's smaller numbers. So 3 times x is 3, so 3 times 3. Minus 3 times y is equal to 12. So this is just a regular old equation. 9 minus 3y equals 12. So we're trying to isolate the y. So we're going to get rid of 9. So we'll subtract 9 from both sides. Negative 3y is equal to 12. And then it's not equal to 12 anymore. It's equal to 12 minus 9, which is 3. And then we'll divide both sides by negative 3. And then y will equal to negative 1. And we'll go ahead and write our solution as x comma y, negative 3 comma negative 1. I can go ahead and plug it back into both equations to check to see if it works correctly. So if x is 3 times 3 is 9. And then we have a minus sign here. 3 times negative 1 is negative 3, so we would have 9 minus negative 3, so that's going to be 12 because the negatives are going to undo each other. Okay, so that looks good. In the second one, 9 times 3 is 27. And then 3 times negative 1 is negative 3. 27 minus 3 is 24. So it looks good in both equations. Okay, so we're going to look at two more, and there'll be a little bit more work involved in each of them. So the next one, we have 3x minus y equals 11. Underneath, for equation 2, 2x plus 5y equals 13. We'll label those equations 1 and 2. So what I'm looking for here is, again, the path of least resistance. So I'm going to look at the x's, and I'm going to look at the least common multiple of the x's, which is of the 3 and the 2, which is 6. So I would need one of my x's to be a positive 6x and the other one to be a negative 6x, so that when I add them, they're going to drop out. I look at the y's. One is a negative y or a negative 1y, and the other is a 5y. The LCM of 1 and 5 is going to be 5. Now, I can eliminate the x, but that's going to require me to multiply both equations by something. If I eliminate the y, because one is negative y and the other is positive 5y, I only have to multiply one of the equations by a number so that they can reach the LCM of 5y, because one of them is already 5y. So what we're going to do is I'm going to write 5 and then 1 with a circle to indicate equation 2. So 5 times equation, did I say equation 2? I'm in equation 1. 5 times equation 1 plus equation 2. Okay, so I'm just going to write equation 1, and then I'm going to multiply it by 5, and underneath I'm going to write equation 2. So equation 1, we're going to multiply both sides by 5. Got to follow the golden rule. Anything you do to one side of the equation, you have to do the other. So 5 times 3 is 15. 15x minus 5y equals 55. Underneath it, equation 2. And there we are with happy times. The 5y's are going to drop out when I add these two equations straight down. So we had to do this extra step to get to here, whereas the previous problem, this was already done for us. They were already opposite signs so that they would cancel out when I add. Alright, so 15 and 2 makes 17. 55 and 13 makes 68. 17x. We'll divide both sides by 17, and x will be equal to 4. And at this point in time, I can either substitute this into equation 1 or 2, does not matter, I will get the same answer. I'm going to substitute it into equation 1 because it has a little bit smaller numbers. So it's going to be 3 times x is 4 minus y equals 11. So we're going to isolate the y by subtracting 12 from both sides. And we have negative y equals negative 1. Okay? I'm going to divide both sides by negative 1. That has nothing to do with the right-hand side being negative 1. It has everything to do with this is actually a negative 1y. So that's why I'm dividing by negative 1. It doesn't have to do with negative 1 being on the right. So I'm going to divide both sides by negative 1. Y is equal to 1. So then I'll go ahead and write my, I guess I didn't write my ordered pair anywhere, did I? Well, let's go ahead and do that. So ordered pair is 4, 1. And if I want to check that in both my equations, if x is 4, 3 times 4 is 12. And then minus 1, 12 minus 1 is 11, looks good. 2 times 4 is 8. 5 times 1 is 5. 8 plus 5 is 13, so it checks out both of our equations just fine. Okay? We're going to do one more, and this last one requires us to multiply both equation 1 and equation 2. So equation 1 is 3x minus 5y equals negative 3. Equation 2 is 4x plus 4y equals negative 4. Okay? So here's what I'm kind of looking at. So I look at the x's. So LCM of the x's, 3 and 4, is 12. LCM of the y's of 5 and 4, that's 20. So these are things I have to consider. Do I want to make the y's look the same or the x's look the same? Now the y's already differ by a sign. One's negative and one's positive. So all I would have to do is make the top equation have a 20y and the bottom equation have a 20y, and then they would, because they're opposite signs, they would cancel out. If I do the x's, I would make them both look like 12, but one of them would have to be negative and one of them would have to be positive so that when I add them they would cancel out. I'm going to go ahead and choose to not fiddle with any more negatives than I already have. So I'm going to multiply the top equation by 4 to make that 5 into a 20. And the bottom equation to make the 4y into a 20, I'm going to multiply it by 5. So that's what we're going to do here. So we're going to get rid of all this red ink. And we're going to take equation 1, and I'm going to multiply it by 4. So 4 times equation 1 plus 5 times equation 2. So I'm just writing this down for me so that when I go back and I look at this later on, I know exactly what I was doing. I know I have access to extra colors, so it's a little bit easier to see. And then, you know, if we want to go back and we're studying this, then, you know, if I wrote down kind of what I was doing, maybe I wrote down in words, then it's a little bit easier for me to follow what I was doing. And then also it's good because it's a good habit to get into, and then maybe I show this on the test, and it's easier for me to follow and award partial credit for correct processes. Alright, so equation 1 is 3x minus 5y equals negative 3, and we're going to multiply both sides of the equation by 4. 3 times 4 is 12, minus 4 times 5 is 20, negative 3 times 4 is negative 12. Then the bottom equation, equation 2, we're going to multiply it by 5. Okay, in each case, 4 times 5 is 20. 20x, 20y equals negative 20. And now you see that when I add the 20 y's, they'll cancel because one's a negative 20, one's a positive 20. Okay, so we will have 32 x's equals negative 32. Divide both sides by 32. X is equal to negative 1. and then I can plug in -1 into either equation. Does not matter. I'm going to get the same value for y. I'm going to go with the first equation because the numbers are smaller. So equation 1, 3 times x is -1, minus 5 times y equals -3. And we're just going to be isolating the y, so we're going to add 3 to both sides. -5y is equal to 0. We're going to divide both sides by -5, and this is 0 over a number that is on. Remember, that is 0. Okay. So y is equal to 0. So my ordered pair is -1, 0 as my solution. Now if I check this, in both cases the y is going to be 0. So whatever I multiply 0 by is 0. 3 times -1 is -3, so I have -3 equals -3 in the top equation, equation 1, so that's good. And then 4 times -1 is -4, and equation 2, -4 equals -4. Works out in both of them. Okay? These will take a little bit of practice, but the goal is to eliminate one of the variables. I think just by coincidence we eliminated the y in all 3 examples. Sometimes the x's will differ by a sign, and those will may be what we want to go after. We'll also do the same procedure for systems of 3 equations and 3 unknowns. It's a little bit more complicated, but the process is the same. You're going to eliminate a certain variable twice, and then you'll have a system of 2 equations and 2 unknowns like we have here. Anyways, that's it for now.